And we are now live with Dr. Henry Throop, who is now based at NASA headquarters. And Henry, you are a fascinating guy for many, many reasons. But one of the first things I've noticed is that when you Google Henry Throop, you get many different explanations on who you could possibly be and what it is that you do. But can you give us the latest update on what it is that you are doing and where you are and that sort of thing?
So I'm an astronomer. I study the solar system. I study the outer solar system, and I've been involved with the New Horizons mission, which went past Pluto and past Ultima Thule. And right now I'm talking from NASA headquarters. I'm running some of the science programs at NASA headquarters right now. And Steve, you and I know each other because I lived in South Africa for a couple of years, where I was based at the University of Pretoria, working to build up the science and astronomy program in Pretoria. And while there, we were doing observations of asteroids. We were doing observations of Pluto from the telescopes outside of Cape Town at Sutherland. And then after living in South Africa, I lived in India for a couple of years, where I was working with a lot of schools and universities to build up their research programs, and doing a lot of outreach with communities in India, and working to plan New Horizons, to plan our NASA spacecraft encounter in the outer solar system to this object called Ultima Thule.
Sure. So would you describe yourself as an astronomer, an astrophysicist, a space cadet? I mean, what words would you use to describe yourself?
Yeah, all those work fine. Yeah, astronomer, astrophysicist, planetary scientist. We all kind of, they all basically mean the same thing. So mostly I study the outer solar system. So I don't specialize in the solar system is made up of, we have the sun here, and then we have all the other planets going around it: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, and then it doesn't end at Pluto. It keeps on going all the way out. So Pluto is just, Pluto is a long way away. It's about 4 billion miles away from us. But that's not the edge of the solar system. It keeps going beyond Pluto. We have what we call the Kuiper Belt, which is many, many small bodies, small meaning tens of kilometers across.
Mm-hmm.
That is where the comets come from. And then you have to go about another 50 or 100 times further than that till you get really to the edge of the solar system, where you start to feel the gravitational influence of the next star over. And so I mostly study the stuff inside our solar system. Don't study things like galaxies and black holes and things like that. Because I really like the stuff inside the solar system. It's close. You can send spacecraft there. You can go there and visit it, and you can take pictures of them.
Well, it's not so simple to take photographs of things that are so far away, and we're going to be talking about that whole process because, if we wanted photographs of the moon, we could pull out a telescope and get some lovely photographs of the moon. But when you're talking about Pluto and even further than that, one has to exercise a little bit of patience because the mission takes quite a while to do that. And we're going to talk about that. I noticed, David, you were showing us something in your on your screen there. There was a New Horizons mission, a participation certificate, shedding light on frontier worlds. Do you know anything about that at all, Henry?
So yeah, we've involved quite a lot of citizens on the New Horizons mission. One of the ways is just in sending people's names along. We have there's tens of thousands of people who have sort of participated in the mission by following us, by encouraging us, and by sending their names out to Pluto and Ultima Thule and beyond. And then there's also many there's probably up to several hundred people who've helped out with observations of our targets, either of Pluto or most recently of Ultima Thule, which is our target in the outer solar system in in the Kuiper Belt. And this is something where we had, we have a lot of astronomers on the team, but we had to really ramp things up and do a lot of observing to plan for this encounter, and we couldn't do that all ourselves. So we drew very heavily on the amateur astronomy community to help us out with a lot of these observations to plan for the flyby.
Sure. All right. Well, let's go back to the beginning. First of all, Pluto. Why is it no longer a planet? What did it do to deserve the demotion? I mean, like, why did they demote it? And second of all, why is it such a challenge to get to Pluto to take photographs?
Well, we still call it a planet. You can still call it a planet too if you want to, Steve. Anybody else can too.
I will, because in my heart, I know it's still a planet.
Thank you. I do. So it's a question of size. And so it's just kind of a question of what, what do you call something, what's the real dividing line between a mountain and a peak and a hill? Is it 1 kilometer? Is it 2 kilometers? Is it 5 kilometers? Where's that dividing line? And so what's the difference between a stone and a rock and a boulder and a massive boulder? Where do you draw that line exactly? And so the same thing happens in the solar system. That we have particles, we have objects of all different sizes. So things that are really big, the biggest things in our solar system, like the sun, that has fusion going on in it. And the sun is close to 1 million kilometers across. Jupiter is 70,000 kilometers across. It doesn't have fusion going on in it because its pressure is not high enough. But we call it Jupiter a planet because it's really big. We call the other big things in the planet in the solar system we've seen orbiting for thousands of years. We've Jupiter, Saturn, Uranus. Uranus and Neptune were discovered on the order of 100 years ago, 150 years ago. And those are tens of thousands of kilometers across. You go down to the terrestrial planets, Mercury, Venus, Earth, Mars. We've known about these things for thousands of years. And we generally call them planets too. And then you keep going smaller and smaller. And you get down to Pluto. Pluto's about 2,500 kilometers in diameter. And you call that a planet. Some people call that a planet. Some people call it not a planet because it definitely shares some characteristics, many characteristics with the planets. It's round. It orbits the sun. It has moons going around it. But it's also similar to the icy bodies at the outer solar system. It's similar to these other Kuiper Belt objects. And we've since discovered hundreds or thousands of Kuiper Belt objects in the outer solar system, which are very similar to Pluto. And so most of them are smaller. Pluto's sort of the king of the Kuiper Belt. It's the biggest one out there. That's why many people still call it a planet. But it's not the only one out there. There are not just 9 objects in the solar system. There's thousands of objects in the solar system. And so as our understanding of the solar system changes, then we kind of revise the names for things too.
Okay, but now why is it so difficult? I mean, if you look at early photographs that people took of Pluto, they were just little pixelated images of a blurry little dot in the middle of nowhere. And then all of a sudden, there was this mission, and now we get the most spectacular high-res photographs of the planet. The first question is, how difficult was it to get to that stage of actually taking photographs of the planet? And that means, I'm implying, the mission itself, the New Horizons mission. And second of all, the technology that you're using today to take the photographs of that planet was from more than a decade ago. So are we really getting bang for our buck?
Well, that's what we got to do. So it takes, Pluto's a long way away. It's 6 billion kilometers out to Pluto, and then it's another couple billion kilometers out to A69, Ultima Thule after that. And so it takes 9 years. It took 9 years to fly out to Pluto, 3 more to get out to Ultima Thule. And so we launched in 2006 from the Earth. Our spacecraft was selected for flight in 2001 before that, and it's proposed in the couple of years before that. by the group that I was at the Southwest Research Institute in Boulder, Colorado. And the most important thing that we wanted to do was get out there. And to get out there, we wanted to make a simple spacecraft. And that means not something which is going to break. It doesn't have any moving parts on it besides the spacecraft itself. It doesn't have any motors or gears or pulleys or things like that, because those are things that are not reliable in space for a long time. And we wanted to use technology which had been proven before. And space is cold, and it can be hot, and it can be, you know, you're in a vacuum and you're shaking when you're in the launch environment and so forth. And so you want to use pretty, you know, proven technology. You don't want to be pushing the envelope here. So yeah, a lot of our technology is from the era of 2000 and before. But that's okay. That's fine. We're not trying to. We don't need to you know, have the fastest processor on there, because what we have is sufficient to do the job, and we're limited by other things. In fact, what we're limited mostly by is the fact that it's dark out of Pluto. You know, we're flying by as quickly as we can, but we don't want our images to get smeared. We have to do long exposures for them, and even using technology today, in fact, our images would be the improvements to the various aspects of the mission wouldn't really change the science that we're doing very much. So we were pretty happy with the spacecraft that we were able to get up there.
When did it all start? I mean, so how long did it take to get to Pluto, and did it all run smoothly from the beginning?
Yeah, so it actually took longer to convince NASA to fly the mission than it did to actually fly the mission out there. It took about a 10 or 15 year process for the community to work together and build up the science case for funding this mission and for selecting it. And there was a competition between you know, many different groups where they selected. And there were about 20 proposals originally, which then were competing against each other until this mission was selected and then ultimately launched in 2006. And then in order to get out to Pluto,
2006 was a long time ago.
Well, 13 years ago, yeah. So we've been basically, it's a straight line trajectory. What we do is we launched from Pluto in 2006, and if you can draw the solar system here, it's a we passed. So we didn't go to the inner solar system. We didn't go to Mercury, Venus. We did go to Earth. You know, we launched from Earth, and then we passed the orbit of Jupiter and Saturn and Uranus and Neptune as we went out, and then we finally got out to the orbit of Pluto and intersected Pluto in its path. We kind of calculated so we would intersect with it, right, like that. The only thing that we took pictures of on the way of note was Jupiter. We timed it right so that we would intersect Jupiter's path right when Jupiter was there, and that actually gave us a little bit of a gravitational kick, a slingshot, to speed us up in our orbit and actually take a couple of years off our trajectory to get out to Pluto.
Sure.
So, but most of that time, we weren't observing things. The solar system, if you're not next to a planet, the solar system looks pretty empty to the camera. And so most of the time we were essentially in hibernation, just like a bear over the winter. And so we turned off the systems and checked in with it occasionally, but we were largely preserving the spacecraft for that encounter with Pluto and with Ultima Thule.
Wow. Well, I mean, I know I can keep asking you lots of questions, but we've got a whole bunch of students that are with us at the moment. I know we've got 2 schools from Brazil. We've got from Russia. We've got India. We've got Hungary. We've got the US. So we've got quite a nice mix, and we've got people watching it live as well from other countries. And I think that maybe we might even have someone from Greece joining us as well. So let's go off to Atalo. Do you have anyone in your class that would like to ask a question? You can ask any space question you like.
I would like to ask a question. I don't know, I've been off and then on again in the session, but do you think we are alone in the universe? Why? Yes or not? I think you have addressed something like that.
It's a great question, and I think probably, you know, that's one of the questions that astronomers get. We get to address, and we get asked a lot, and we get to think about a lot. I mean, this is kind of one of the big questions of humanity: is, are we alone or not? And You know, you can break this down into you know, is the Earth alone? Is the Earth, you know, it used to be that we thought the Earth was the only planet and everything went around us, but we know that that's not true. Now we know there's, in our solar system, there's other planets. There's Mercury and there's Mars and there's Venus and so forth. And then we used to think that the solar system was the only solar system, but now we know there's, you know, hundreds of solar systems just even very close in our galaxy, and probably throughout the whole galaxy and throughout the universe, there's solar systems all over the place. And so we've seen other galaxies, we've seen other solar systems, we've seen other planets elsewhere, we've seen all this stuff, but we've never actually seen any life anywhere else. We keep looking for life. We keep listening for signals. We keep looking for life on Mars or in, you know, the other planets in the solar system. We haven't found any, but we haven't really looked at all beyond the, you know, in many of these areas. For instance, on Mars, we've only looked on the surface. We haven't really looked below the surface. And we're only looking right now. Now, it might be that on Mars, maybe there was life on Mars in the past, and so what we would be looking for in Mars would be like fossils, the remnant, the kind of the fossils of previous very early life. There's a lot of other places in the solar system that if you want to look for life now, you might go to. For instance, there's a moon of Saturn called Enceladus. And Enceladus is unique because it has liquid water near the surface. If you look at, we can study a lot about what we might expect life to look at by looking at life on Earth. For instance, all life on Earth requires liquid water. And so if you look for, let's not look for life, let's just look for liquid water. Where do you find liquid water? It's not very many places, but Enceladus is one of them. Here's another one, which is Europa, which is the moon of Jupiter. And Europa has an ocean. It does not quite at the surface, but it has a thin layer of ice, and then below that layer of ice is a lot of water in the ocean. And so if you want to search for life, just go to Europa or go to Enceladus. And it's wet, there's a lot of water, it's warm, there's energy there, and they might be really, really good bets. So those are of a lot of interest to NASA and to astronomers and to people and, you know, researchers in other countries as well in the next decade or two.
That was a great answer. Now I know we've got Sam who's got a question, and Joe's got someone in his students as well. So Sam, you want to go first? You must just unmute yourself.
Okay, I can ask.
Yeah.
Okay, well, students here asked how long it takes from Earth to the moon.
Good question.
And one of the students also said, I think there a planet was discovered, a new place was discovered that was very similar to Earth. Do you know anything about it? I don't know where he saw it.
Yeah, so I missed the first part of the question with the moon, but let me answer
how
the
long
second
does
part.
it take to get to the moon? How long does it take to get to the moon was the first question. Yeah.
Okay, so for getting the moon, very easy. So with New Horizons, we crossed the moon's orbit, and we crossed the moon's orbit in 9 hours. And so that means it took us 9 hours to get to the moon. Now, we didn't land on the moon. It took the Apollo astronauts longer to get to the moon, and that's because they had a much bigger spacecraft, because they had to take, you know, the people, the food, and the lander, and all that. So they were going slower. This is just conservation of energy in physics. If you have a big thing, it'll move slower, given the same amount of energy than a small thing. And with New Horizons, since we didn't have any people on it, or any you know, food, anything like that, we moved much faster. So the moon is measured in thousands of kilometers away, rather than in millions. So it's relatively close. And even, yeah. So okay. So second, and let's see. I'm sorry. Second question was. Remind me.
The second question was, now you see, even I've lost the plot. Just unmute yourself, Sam. This is what happens when old age starts setting in. We start forgetting these things.
Okay, the second question was if there was any planet similar to the moon. Yeah, because one of the students said they found out something.
Yeah. Okay. So for other planets, not exactly similar to the moon, but we do have a lot of planets that we found which are pretty similar to the Earth. Now these are really interesting because they're not planets which are in our solar system. So in our solar system, one of the main things that determines properties of a planet is how close to the sun it is. And so if you get closer and closer to the sun, like Venus and Mercury, then it's really, really hot. If it's really, really hot, that means that, there can't be any water there, there can't be any ices there can't be much of an atmosphere there because it all gets boiled off. And then as you get further and further from the sun, things get colder and colder, and you have more and more ices. So you get out of Pluto, and things are really chilly, and a lot of snow on the surface from the atmosphere snowing down, and ices make up a lot of the mass. So we can't find any other planets that are really like Earth besides looking for the ones that are right next to us, like Venus and Mars. But if we look around other stars, in other solar systems, around other stars, which we've been able to do in the last decade or so, we've actually found, it's on the order of several thousand planets around other stars, and we call these things exoplanets because they're planets which are beyond our solar system. And we haven't exactly found an Earth yet, but we found a lot of planets which are very similar to the Earth, meaning they have roughly the same size as the Earth, roughly the same temperature as the Earth, and those are the main things which determine the properties of the planet. Now, we haven't been able to take photographs of these yet. We've kind of been able to measure them and measure their existence, learn a little bit about them, but we don't know, what color are they? Do they have continents? Do they have an ocean like us? What do they look like? We don't know these things yet, but over the course of the next decades that we build some of these really giant space telescopes, we will be able to learn more about these exoplanets and figure out how similar to the Earth some of these things really are.
Okay. Great questions. I know Joe's got a question, and David, your class has got a question as well. So we're going to go to Mr. McNulty, your class first.
Hi, I'm Gabby. Oh, wait, can I say that?
Camera's right there, Gabby.
Hi, I'm Gabby, and we're from Pennsylvania, Holland, Pennsylvania. So I know this question's kind of like went over already, but what are the chances of finding a new human-like civilization similar to ours? Like as advanced as ours?
So what's the chance of finding a new human-like civilization? Well, we don't know. We don't know. Here's the thing. It's so we can look in two places, basically. You can talk about looking in the solar system for life. And looking in the solar system for life, we're probably not going to find humans in the solar system because if they would be here, we would have found them already. We've gone to Mars, and there's certainly no life that's obvious on the surface of Mars. I mean, there's no kangaroos jumping around or people or anything like that because we would have seen them already. Mars right now is pretty dry and dead. Now, it hasn't been there forever. Mars used to be warm and wet, but that was billions of years ago. Now it's pretty dry and dead. If you wanted to, when other places in the solar system, if you go to Europa or Enceladus, which are these moons of Jupiter and Saturn, you might find life there, but it's going to be hidden. It's hidden below the shell of ice. And right now, we haven't been able we haven't looked below that shell of ice to see really what might be there. It might be teeming with life there, or it might be completely dead too. So we don't know, but we're interested in looking for sure. And then those are the places where you would want to look inside our solar system. Now, if you want to look outside our solar system, there's a whole lot of more possibilities out there. It's also a lot further away, and so it's much, much harder to search with telescopes, and it's much harder to actually go there with a spacecraft, because instead of taking 10 years to get there with a spacecraft, it might take you 100,000 years to get there with a spacecraft. And so we can't explore these quite as easily. You know, as telescopes we get these larger space telescopes up, then we'll be able to study these things better and better from the Earth.
Well, I think that teachers, we all know that aliens do exist because we've been teaching many of them for so many years. It's no secret. They've been living amongst us because some children, whew, you know how they behave. Now, David, I see someone in your group has got a question. Sure, go ahead. We've got no sound, so maybe your Are you muted? No, no, no. When you unmuted yourself, we still had no sound. So, no, we still can't hear you. So your microphones, maybe you must just check your settings to see if your microphone is activated on the webcam as well. Okay, we'll come back to you. We'll give you a chance just to get the technical stuff right. Let's have a look. So Henry, I mean, you obviously, you send this rocket. It travels from 2013 all the way to 2019. No, you said
2006.
2006. Sorry. Some of the students in Mr. McNulty's class were only born in 2006, which means that while they've been living their life, this thing has been traveling most of its life towards Pluto, and then it went past Pluto. And what was the next big object that it was chasing after?
Yeah, so we've essentially we flew past Pluto in 2015, and that was the goal. Our goal was to go past Pluto. But at that point, then we had this great spacecraft, and the spacecraft was still working, and it had done its job to go past Pluto. And Pluto's not the end of the solar system. So what we wanted to do is find something else for it to go past, and that would be exciting to have as a target. But more importantly, it would tell us more about the history and structure of the solar system. And so a little bit before we got to Pluto, we started searching for other targets in the Kuiper Belt. Now we can steer our spacecraft a little bit. We can't, have it do a U-turn and a, hard left here and so forth like this. We don't have, that takes a lot of fuel to do these sharp turns. But if we could find something which is more or less our path, where we could just do a little turn in the Kuiper Belt, we could redirect it to go past this. So we spent a number of years using some of the largest telescopes on the ground and searching for something else in the solar system, something else beyond Pluto that we could go to. And we knew there were many objects out there. We just knew that there weren't any that were on our path that we knew about. So we used some of the largest telescopes to search, and we searched and we searched, and we were like, nothing, 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 nothing. And after 5 years of searching, we were like, so we gave up, and we said, there's only one telescope left that we can do this with, and that's the Hubble Space Telescope. And it's not the largest telescope in the world, but it is the most sensitive for looking for very faint, small objects like these are. We didn't start with it because it's really, many people want to use it, and you only want to use Hubble if you can really show that nothing else will do the job. But here we couldn't find anything, so we knew that nothing else could do the job. So we applied, and we got some time on Hubble, and we searched. We spent quite a bit of time searching with the Hubble Space Telescope. We actually found 5 objects in the region of the sky that we were looking, and these are 5 icy bodies. So these are very, very ancient, old. These are smaller than planets on this scale of not hundreds or thousands of kilometers across, but on the order of tens of kilometers across, 10 or 20 kilometers across. So we found 5 of these. 2 of them were too far away. We would have to turn too much to get to them, and so we had to rule them out. That left us with 3 of them, and then we picked the one of these that was closest to us, to where we could get to most easily with the fuel that we had. And this one had the name of 2014 MU69. We kind of gave it a nickname called Ultima Thule. Ultima Thule is a Greek word that means basically the outer limits, the most unexplored area of as far away as you can get. And we calculated out and worked out that we could get to Ultima Thule by burning our engines, and we actually arrived there on January 1st. 2019. Now, Ultima Thule is really small. It's a very different part of the solar system because it's further out, and it's a scientifically a really, really different thing to explore than the planets in the rest of the solar system.
Okay. Now I know David's going to try and see if his microphone is working. You're holding thumbs, or maybe other fingers too. Let's go for it. No. We're not getting sound from you, David. So your question was, and I believe it was Juliana, she wants to know, The question was, is Pluto at a point in its orbit where it has a slight atmosphere?
Yes, that's right. So yeah, Pluto, you know, it's kind of like a yeah, it's kind of like if you've played with dry ice before. You know, if you have dry ice, and dry ice is frozen carbon dioxide, and if you put it in the freezer, it's really cold and it'll stay there for a long time. But then if you warm it up, if you put it outside in the sun, it'll sublimate away and turn to gas. And then it turns out that, you know, if you make it cold again, you know, if you go to a dry ice freezer where things are really, really cold, all that gas will actually come back down and form the dry ice again. Pluto's exactly the same way. It's made out of the same stuff that makes up our atmosphere, made out of carbon dioxide and methane and nitrogen and so forth. And all these are frozen out of Pluto. But as Pluto gets a little bit closer to the sun, some of that stuff boils off and goes into the atmosphere. And then as Pluto gets further away from the sun, then all those gases condense out and they freeze out onto the surface. And so Pluto's orbit is a little bit elliptical, and that means it gets closer to the sun and further from the sun as it goes through its orbit. It takes 250 years to orbit the sun, and so every 250 years its atmosphere gets a little bit bigger and then a little bit smaller, a little bit bigger and a little bit smaller. Now when I say it's smaller, its atmosphere is very small compared with Earth. It's actually about 100,000 times less atmosphere than there is on the Earth. The atmospheric pressure is. So it's nowhere near enough for you to breathe. It's nowhere near warm enough for you to walk around there. But if you're measuring its atmosphere and you're trying to study what it's made of, it's certainly enough to see it and to detect it.
Well, they were quite appreciative, and they said thank you. They're also at Newtown Middle School. And then, Mr. McNulty, you've got a question from your class.
Yeah, we're here at Holland Middle School, and she'll introduce herself. Go ahead.
My name is Lily. I'm also a really big fan of astronomy, and I was wondering what his favorite planet is.
Oh, is that a tough question? Your favorite planet?
Oh, well, you know, I think I'll answer with two. Number one's got to be Pluto, because you know, it's always been the underdog here, and it's the different one. It's the different one, and it doesn't fit in with all the other planets. And what we've learned about it just in the last decade or last 3 years since we've gone past it just keeps surprising us. We thought that Pluto would be really cold and really ancient out there, and the big shock with it was that it's a much newer, warmer surface than we thought it would be. We thought it'd be completely covered with craters, for instance, because craters in the solar system are how you can tell how old the surface is. And Pluto looks like it actually has a much younger surface than what we thought it would have. And so we were baffled when we got there. We were all of our predictions were wrong. The other planet that I love is Saturn, just because.
We lost the feed.
We've lost Henry for a bit. Hopefully he'll rejoin.
Yeah, it is interesting.
So
cool. He's back. We lost you there for a second, so you're gonna have to repeat just that last little bit.
Okay. Do you repeat about Saturn?
Yeah, just from the Saturn part. Yeah.
Okay. So the other beyond Pluto, Saturn is also just a planet that is awesome because it looks so different. We see this ring system on Saturn, and you can see Saturn in a backyard telescope very easily, and you can see its rings, and the rings look just so three-dimensional. They look like these like all these NASA images that we get, and but you can see that yourself just looking at it through a backyard telescope. The rings made of basically broken up moons and comets and things like that, which go around the which orbit around the planet, mostly ices, and they just give another. It's just surreal to be able to visit it and to go up and see it in your backyard and experience Saturn like that.
But not everyone gets the opportunity to see it in their backyard. Although it was actually at Sci-Fest one year, they pulled out the telescopes and I got to see Saturn. And frankly, I thought someone had taken some clip art and just stuck the picture in front of the microscope, I mean the telescope, I couldn't believe that is exactly what Saturn looked like. I was quite blown away by that.
Yeah, it's really nice. I hope that everyone can get a chance sometime. It doesn't require a huge telescope, but can get a chance at a local observatory or with friends who have a telescope to see Saturn, because it's really dramatic and beautiful.
Awesome, awesome. So now, Sam, you've got 1 or 2 questions with your group?
Okay. A student here asked if you believe we could adapt easily to the atmosphere of this planet, these planets that are similar to Earth.
Yeah. Okay, good question. So can we adapt to the atmosphere of other planets? Right now, we don't know of any of the other planets which have an atmosphere which is like ours. So there's only one other place in the solar system which has a really thick atmosphere, and that's Venus. Well, Venus and also Titan, which is the moon of Saturn. And but both of these are not good places for us. Venus is just way, way, way too hot. Titan is way, way, way too cold. And so the composition of that atmosphere is not very good for us. We actually require a pretty, humans require a pretty sensitive range of atmospheric composition and temperature. So, the Earth is the right place to be. Let's make things right on Earth. Let's clean things up here and keep the Earth's atmosphere right for us, rather than trying to live someplace else.
All right, and I see that Jairus has joined us as well. He's in Kenya. Jairus, do you have any questions that you want to ask?
No, I'm just here to listen and learn.
He's just there to listen and learn.
I want to know. Yes.
All right. We will. If you do think of a question, just let us know, and we'll give you a chance. I know that Mr. McNulty's got a group that want to ask a question.
Yes, we do have a couple questions. Why don't you come on up, introduce yourself? You go ahead, and then can you ask a question? We have 2.
You can have 2.
Hey, come on up to the camera. Here's your microphone. Be loud. Go ahead.
Hi, I'm Lena. I just have a question. How long do stars live, and how do they die?
I'm sorry, say it again.
How long do stars live, and how do they die?
How did what live?
How long do stars live? And then and how do they die? I mean, what goes around killing these stars? Is there a planetary or sun killer or something that lives out there?
I wish. So stars live and die because they go through all their fuels. Basically, if you just have a big pile of hydrogen, start off with a cloud of hydrogen, gravity pulls all that hydrogen together, and because gravity pulls everything together in the universe. And when that hydrogen gets pulled together, all the molecules, all the atoms, they get smashed together and they turn into other things. They turn into helium, and then they turn into carbon and oxygen and iron. They keep just turning into other metals and other elements. And eventually they can't do that anymore. In fact, iron, every other element, if you smash it, if you push it together more, it'll turn into something else. But with iron, once they get to iron, they can't do that anymore. And depending on how big your star is and what it starts off with, it will either stop there or stop somewhere else, because it can't basically, we say if stars burn, but they don't really burn like a flame, but they can't keep doing any more chemistry. And so sometimes with the largest stars, you get a supernova, you get an explosion that happens. With other stars, they just go through they get a little bit brighter, and then they get duller, and they eventually are just going to essentially blow themselves apart in more calm, peaceful ways. And then what's cool about that, it's kind of like recycling. After a star has burned out, and all of its elements are put into the next generation of stars. And so the stars, they take in hydrogen and they make that into other elements, and then those other elements go into the next generation of stars. And so all of the elements in your body and all of our bodies were made from one generation of stars. And when our solar system is finished, ultimately all of us will go into the next generation of stars after that too.
It's always good to know that we are being recycled. I like that.
Yes, absolutely.
All right. And who's next? Go ahead.
I'm Jonathan, and my question is, do you think that SpaceX is better than NASA?
That's an interesting
Oh, that's a great question. So, yeah, so SpaceX is doing great things. SpaceX is not doing the same as NASA. NASA is the federal government agency which funds and oversees all of the exploration in the program. And what SpaceX is so NASA funds astronomy research, and NASA employs astronomers, and NASA sends out spacecraft to different parts in the solar system. What SpaceX is a company that builds rockets, and there are a lot of companies in the U.S. that build rockets. Other ones, like you've heard of Lockheed or Boeing, companies like this, and they all build rockets. But SpaceX's rockets have done really well, and they're doing a lot of innovative things with rockets, like reusing them. And instead of just sending them up, they send them up and then they land down again too. And so there's a lot that you can do by reusing rockets, because you can do the same as what you're doing before, but you can do it better and you can do it cheaper, and things like that. And so SpaceX is one of the companies that NASA is using to. SpaceX is selling rockets to NASA. NASA is using those rockets to in the future to explore the solar system, and it's a together SpaceX and NASA can do great things.
Well, I mean, if you think about it now, we're talking, they just recently had a very successful launch of the Dragon unit that will be carrying the US astronauts to the International Space Station. And that'll be the first time that America has been launching its own astronauts since the end of the shuttle program. So lots of exciting things are happening.
Yeah, that's right.
But then, of course, you've got Virgin Galactic that is now doing commercial space travel, where people are buying tickets to fly out of Earth's atmosphere just for a short while and coming back and literally being labeled as astronauts. The last trip, there were 3 of them, and there were 570, 571, and 572.
Yeah. So it's not, it's really nice to see all the different commercial companies that are involved in space and getting people out to space in different ways. So the things like Virgin Galactic, like, if the Earth is here, Virgin Galactic doesn't go very high in the atmosphere. It goes about 100 kilometers up. And so that's very different than, flying to Jupiter or flying even to the moon. The moon is about a couple 100,000 kilometers away. Jupiter is, tens of millions in millions of kilometers, a billion kilometers away. But there's so much innovation and development and new ideas from all these companies in terms of different ways to get into space and get people into space, and also get robots into space, because most of the solar system exploration that we've been doing isn't using people, it's using robots. The robots are cheaper, smaller, faster than people in many cases.
So there's obviously hope for AI. I see Sam has got a question for us as well.
Can you see me?
We can see you and we can hear you.
Okay. The question is, a student wants to know if it's possible to plant. I mean, would anything grow in other planets?
It's a very good question.
Yeah, we haven't tried that yet. We tried a little bit in 1976. There was a mission that went to Mars called the Viking mission. And they basically, one of the things they did was they took along an experiment, which was actually looking for life in the surface of Mars. And so they were looking for bacteria. And they basically fed a little mixture of you can think of it as being sugar to see if there were any microbes and little bacteria on the surface of Mars, and you could see if they would eat it. And so that's exactly like a plant, but it's like a small plant, to see if it would survive there. And the results there were, we don't know exactly what those are, but it wasn't obviously, it didn't obviously show that there was any bacteria on the surface. Mars would be probably the best place if you did want to plant something. In general, let's see, the soil on Mars, we haven't tried to plant anything there, but if you brought it back conceptually, if you there's no reason why you wouldn't be able to plant something there. It's not as worn down as the soil on the Earth, and maybe the let's see, but chemically, it's more or less right. Yeah, you need oxygen. You need the
need oxygen, but you could create. I mean, if you're going to put in an environment, it makes no difference which planet you put it on. As long as it's living in that environment, it's still going to have all of the nutrients and the oxygen and things that it needs. But what Samantha's asking is, could we genetically modify perhaps a plant that could live with nitrogen instead of oxygen, and maybe survive on another planet?
At this point, we can't do that. We haven't done that. Maybe in the future, but that's going to require changing the chemistry of the plants quite a bit if they want to live on nitrogen instead of oxygen or carbon dioxide. So no, yeah. So you could the soil is more or less right, but you have the atmosphere and the nutrients and the water as well. So it's a ways off. It's a ways off from being able to plant the plants that we have now in other places.
But theoretically, it's possible.
You need to have all the right components there. You need to have the atmosphere. You need to have energy from the sun. You need to have the nutrients. You need to have water. If you have all those things, then yeah, no problem.
Okay, well, you see, no problem. No. so what I'm keen to know about is a little bit more about Mars. Why are we sending rovers to Mars and not people? And what is the latest rover InSight actually doing there that the others were?
Yeah, so InSight is a lander, not a rover, and it's landed there recently, and it's looking not at. So we've sent a number of rovers that have gone around the surface, such as the Mars Curiosity rover and the Spirit and Opportunity rover, and so they have their wheels and they drive around the surface and have been exploring it, basically to look at the history of water on the surface of Mars. InSight is looking not at the surface, but below the surface. It's looking for the interior, and so it's looking for on the Earth. We have earthquakes on the Earth because we have the core of the Earth and the mantle and plate tectonics and so forth. And InSight is essentially looking for the same thing on Mars, and we can call them Mars quakes on Mars. Now, Mars, we don't expect to see as much activity from the core on Mars as we do on Earth because it's older, it's smaller, it's cooled off, it's more dead. We don't see as much activity, and we don't expect to see as much activity there. But what it's looking for is remnant activity, which is still there, even though Mars is cooled off and is pretty dead geologically. So we're looking for Mars quakes. We have a thermal probe, which is looking for heat flow, which would be coming out, kind of like looking for geothermal activity, like what you would get from geysers, like the Old Faithful geyser in the U.S. or these geysers in Iceland and Greenland and things like that, like the hot springs. And so we're essentially looking for those kinds of things, because if you could find hot springs on Mars that are heated from the interior somehow, ooh, that might be a really nice place to look for life.
If there was going to be an announcement about Mars that would get you all excited, what would that announcement be?
Oh, let's see.
The headline stopper, the one that's a big deal.
Finding insects flying around the surface.
Well, that we probably wouldn't see. But I mean, if they said, for example, geysers have been discovered on Mars, or perhaps we've measured a Mars quake that is like 9 on equivalent to the Earth's Richter scale, what would that mean from a life point of view?
Yeah, we've studied Mars a lot. I mean, we've had 50 or so missions that have gone to Mars, and so while we can always be surprised by it, the discoveries that we're making at Mars are definitely on on refining our knowledge rather than being shocked out of the water by huge unknown things that we haven't seen yet. So it's probably going to be something on that latter side rather than something which is wildly unexpected, which we had no hint at.
Okay. And then there's a question. David wants to know, on Pluto, if you hit a golf ball or a baseball, would you be able to literally launch it off the entire planet? From a gravity point of view, and obviously from the size, it's a small size.
Yeah, almost. If you did it on an asteroid, you could. Unfortunately, with Pluto, the surface gravity is, let's say 1/10, 1/20th of Earth, something like that. And so you would still need to hit it at many, many hundreds of meters per second, which is faster than you could actually hit a golf ball or baseball. You know, you could probably rig up a system. You could rig up a system of pulleys and one ball hitting another ball, and you could do it. You could eventually do it because there's no atmosphere to slow you down. You could probably work out a system to do it, but just by hitting a baseball in a baseball park on Pluto, you wouldn't hit it off the planet.
I love it. I love it. And now Samantha wants to know, is it true that NASA is planning to take everybody to Mars?
No, I don't. You know, NASA is definitely interested in exploring the solar system. I think maybe Elon Musk wants to take everybody to Mars. But you know, NASA is definitely, you know, there's a new program at NASA called Moon to Mars, which is about human exploration of first the moon and then a human exploration of Mars. And so definitely NASA has an interest in exploring Mars, not just with robots, but with humans. And you can read more about the Moon to Mars program. But this is still largely a program of scientific exploration. It's not a program of like taking everybody on Earth and moving them to Mars because it's a better planet or anything like that. It's of sending a small number of people there to explore the history and explore the history and science of Mars, and also explore how to explore how people operate when they're exploring space.
Sure. Well, I mean, I know that obviously Mars is not a simple journey to get there. I mean, if it took so long to get New Horizons to Pluto, but there were no humans on New Horizons, and it was pretty small. What would the challenges be to get to Mars with a slightly bigger rocket and human beings in it?
Yeah, that's the thing. It's so much harder to send humans through the solar system than it is to send robots through the solar system, because a robot is small, takes care of itself. You can turn it off when it's to make it easy, and it's self-contained. It just needs, essentially just needs to be built well, needs power, and then it's going to work. Humans is extremely difficult sending humans anywhere in space compared to robots, and so that's why we've done so well with robotic exploration of the solar system. With humans, you can figure on maybe 100 times more expensive than with robotic exploration. You definitely get more out of seeing a human there than getting a robot, because the human can move around and they can use their own, they can use their brain and be a geologist walking around the surface, which is faster and more efficient than having a rover that sends a couple of pictures back and they process them, and then it thinks about where it wants to go the next time and so forth. So it's faster, but it requires an immense amount of work to design life support systems and design transport systems and so forth for human exploration. And so that's why we've spent NASA and other agencies that are doing exploration of the solar system, such as the Japanese Space Agency, JAXA, and the European Space Agency, and the Indian Space Agency, ISRO, and these other spaces, SANZA, the South African National Space Agency, and all these countries have really spent most of their effort on robotic exploration of the solar system historically.
Well, I mean, I do think that if you think about it logically, AI, we could send a preparation party where the devices will land on Mars, will literally build up habitats and stuff using AI. We'll be able to prepare the base for our arrival so that when we get there, everything is already set up and we don't have to try and put living quarters underground, because as we know, the radiation on Mars is quite dangerous. So, I mean, but we're still quite a long way away from that. Do you think that the 2030 estimate is a little bit too frivolous, or maybe it's not conservative enough? What do you think?
It takes a lot of effort to get out there. So, you know, I can't estimate a time scale better than anybody else, but it's a lot of engineering. It's a lot of money. I think that the main question is an issue of the funding available for it. It's not because it's a new area of development. We know how to spend humans in space. We've done this before. We've gone to the moon, but going to Mars is just orders of magnitude more difficult. So it's a question of time and money.
And if you had a chance to be a part of that first mission, would you do it?
You know, I wouldn't turn it down, but I am really lucky that we have done so well with robotic exploration for the solar system. I mean, going to Pluto, you don't really want to send humans out there. Even sending the smallest, lightest, fastest spacecraft we can. It's 9 years to go out there, right? And so that does not sound like a very fun 9 years as a human. So there are a lot of places where, you know, robotic exploration is definitely the what you want to do, and that's just better than sending humans out there. A lot of things humans can do too. So both ways.
One of the questions I have to ask you before we even depart is, of course, every superhero has an origin story. So what is your origin story? Where did you get so excited in science and space and technology? And how do people, especially young people, get into what you're doing?
So I went from the U.S. originally, and I had a great high school physics teacher in Oregon, Corvallis, Oregon, and he, you know, just was really excited about exploring, using physics to explore the world around us. And I remember, like, you know, learning about conservation of momentum and conservation of energy, and then going skiing after that. And I was thinking, like, oh, all this energy is being converted from kinetic energy to potential energy, so I'm going up this hill and so forth. And physics is all around us. And then a couple years later during college, I had the opportunity to do some astronomy research and learn a little bit about the solar system. And that was just so cool. I think the solar system is so interesting because it's a long way away and it's mysterious, but it's also close enough that we can send a spacecraft out there to visit it. And so I was interested in this. I went to college, studied physics, and then I went to graduate school and got a PhD in astronomy from the U.S. and University of Colorado. And I'm just so lucky that we're in a time where we get to explore the solar system and we get to explore the world around us, doing all this all the astronomy programs through many, many countries working together across the world, and be able to talk with you, Steve, and be able to talk with all of these students and classrooms and teachers across the world. And it's such a great time to be able to do this. So it's great.
Wonderful. So now, a parting message, if you want to give advice to the youth in terms of, you know, where they should be heading, if they want to put themselves on a trajectory, a New Horizons trajectory to being space scientists, what do you think they should be doing right now?
Yeah, what we get to do is just ask questions and work hard to answer them, and that's you know, it's nice that we're in a place where we can do this, and being curious, asking questions is the, you know, it's why we're here. It's why we can explore. It's why what we'd like to do as humans. And so you know, every student likes to do that. Sometimes students ask too many questions for their teachers, but you know, the best teachers love those questions and love challenging their students with more questions. And I love seeing that today. And so, you know, all of you have all these great chances to do that and keep being curious and keep exploring. So please keep at it.
Well, what I would like to do is thank you for giving up of your time. I know that you're a busy guy at NASA headquarters. You're busy rubbing shoulders with all these interesting and fascinating people over there. Are you cracking any invites to all the big Apollo events that are happening over the next couple of months?
It's 50th anniversary coming up. That'll be exciting. Yeah.
So do you think you might be able to crack a couple of invites? You never know. You never know.
Yeah.
You're welcome there, David. Thanks for joining us as well. And for all those people that joined us, we had Jairus in Kenya. We had Talo and Sam in Brazil. We had India. We had Russia. We had South Africa, Cape Town. And of course, we had a whole bunch of people who are watching it live on livingmaths.com. And obviously, because the Humans to Mars Summit is coming up in May, we will hopefully have some more space-related interviews for you guys to watch. And are you going to get a chance to go to the Humans to Mars Summit? Because it is happening in your neighborhood.
Yeah, many people from here will be. Actually, I have some other programs that I'm working on during that time, so I'm not going to be at that meeting, but I know it's going to be exciting.
Okay, awesome. Well, thank you very much. Lovely to reconnect, and we'll be following your progress with great enthusiasm, because I know that you love sharing all the latest developments and all the things that are happening in your life, and we love following that as well. Jairus, you don't have any questions you want to ask quickly before he goes? You're going to have to unmute yourself. There we go.
Okay, can you hear me now?
Yes, we can.
Oh, I'm just happy. I'm just happy for the wonderful presentation. I have learned a lot. And I know I will share with my students.
And
great. Thank you, Jairus.
In Kenya, and you know, it's amazing that the technology allows us to just share this with everyone around the world and democratize science.
Yes. Okay, have a wonderful time.
Okay, you too. So now one more request, Henry. You need a big smile and look at your camera so that we can get a photograph of you. Are you looking at the screen or the camera? Oh, there we go. Another one. Because you know what happens? Sometimes YouTube, let me just stop the broadcast here.